This is Algebra 2, Lesson 6.6, Solving or Graphing Systems of Inequalities. So Systems of Inequalities. All right, Algebra 2, Lesson 6.6. All right, so when you think about a system of inequalities, first off, you have to understand what is the solution. And so, number one there, the solution of the system is all the points of, what would you put in that blank? And hopefully you would say all the points of intersection. All the points of intersection. So if you look at the example below, we've got a couple things going on here. So we graphed a parabola right here. And so the parabola would have been a less than or equal to. Because it was a less than or equal to, we have a solid line along all the points of the parabola, meaning those points are included in the solution, right? And then also, because it was a less than or equal to, we had to shade the solution set. And so we shaded inside, and you can see this gray shading inside the parabola. All right, so all of those solve the parabola. Then we had a line here. So we had a linear inequality here, and this would have been a less than, just a less than. Because it was less than, we did a dotted line, meaning those points are not included. And also because it's a less than, we shaded the points of the solution set, the less than part of the line, right below the line. And so we end up with the green. So what would be the solution to the system? All right, well, the system is the point of intersection or the points of intersection of both. So where does gray intersect green? And you can see it's right in here. Now, every point here of the parabola is part of the solution because it's both green and blue. All the red is part of the solution as well. However, each point along this line is not part of the solution because it is dotted, right? And it does not solve the green, all right? So really, when you look at it, what is the solution? The solution is actually all of the red, also the points, and probably if I were wise, I would do this as well and come along my parabola in red to indicate that all of those points are also part of the solution. Okay? So, a key concept, what is the solution to a system of inequalities? It's the points of intersection. The points of intersection. Okay, let's take a look at a couple examples here. All right, let me lower this a little bit. So, all right, so we've got a couple examples here, and so this is some special situations and things that you just need to be aware of. So how would you graph an x greater than or equal to 0? What does that mean? All positive x values, right? That's interpreted. Any value greater than 0 is, you know, a half, 1, 7, 9. Any x value that's positive. Okay, so what does the graph of that inequality look like? Well, because it's all the x values, and those positive x values are all over here, right? Because again, that's a positive 1, a positive 2, positive 3, positive 4, right? So we're looking at all the values there. And so what we would have is a solid line along the y-axis, and we would be shading this side of the line. That is the graph of x greater than or equal to 0. Okay, that's going to come into play later on when we end up doing systems that involve linear programming. Okay. All right, and then look at the second scenario. Y is greater than 0. All right, could have done greater than or equal to, but I chose greater than to refresh your memory on the dotted line. So what are we looking at? All positive y values. Well, again, on the y-axis, this is 1, this is 2, this is 3, etc. So really, this is a dotted line along the positive x-axis, right? Dot it. And where do you shade? You shade up above. And again, here's what we're saying. No matter what point you pick, let's pick this point right here. What's the y-coordinate? Positive 3. What's the y-coordinate? Positive 1. You know, we could come way up here. What's the y-coordinate? I don't know, positive 8 or something like that. But you know, if you come below, okay, that's got a negative value. That doesn't work, right? That one's no good. That's got a negative y value, 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 negative y value. None of those work, right? All the ones up above, keep hitting my keyboard, sorry about that, are the ones that work. Okay? All right, so keep those in mind. Those will come into play. You know, sometimes when you have a system up here in our main illustration, I showed you two inequalities. Well, let me show you this situation. What if I were to add the x greater than or equal to 0 to this? What if I were to add the x greater than or equal to 0? So what would that be? That would be now a solid line here. That would be what? Blue shading here. And now we need where all three colors are. And the solution to that would be just in this section right here, right? So, and if we were to further add in the y, oh, and I just did y. That's really good. All right, you just got to check yourself, I keep hitting my keyboard. Sorry about that. It didn't look right to me, and I was wondering, yeah. All right, I'm this way. Oh, brother. Right, we should be here. All the positive x values are this way. Hey, what if you also did y greater than 0? Then you would be here, right, going this way. And now you need, where do you see all four colors? Well, it would be way in this little itty bitty area right here, right? That's the only place you have all four. And that would be the solution to that system. Okay? All right, let me get rid of all that and clean that up a little. But that's the idea. That's the concept here. We're dealing with systems, So let's do an example here. All right, let me get this a little bit higher. Okay, so here's what we've got. We've got a system of inequalities, and we need to graph them. All right, so a little reminder here. I tried to remind you. First off, over here to the right, there's graphing form for quadratics, right? Also here, I reminded you, how do you graph a quadratic? Plot the vertex first. Use the line of symmetry. Don't forget the shade. Okay? All right, so let's go through. Looking at the blue one here, is it a max or a min? Hopefully you said a min. Got that ugly black again. All right, wonderful. It is a min. And does a min open up or down? Hopefully you remember it opens up. What are the vertex coordinates? 1, 1. Therefore, what is the line of symmetry? X equal 1. Remember, this is how you start, and this is how you graph. So what do I want to do first? I want to plot this vertex. So let's plot the vertex first at 1, 1. All right there, 1, 1. The rest will take place with an XY chart. I keep hitting that one below. My orientation is just a little off here, and I've got to be careful to be above quite a bit. All right, XY chart. So I'm graphing the blue, and so I'm already at 1, 1, so I'm going to do 2, right? Again, look here, I'm already at 1, 1. So I'm just going to go 1 point to the right, and that's a 2. Right? That's what you're thinking there. All right, so when I put 2 in, again, I'm putting it into this part of the function, right? Trying to figure out the y. So again, just to show this, right? Put in 2 where the x is. 2 minus 1 is 1. 1 squared is 1. 1 and 1 is 2. And you get the 0.22. All right, 0.22. And let's remember our line of symmetry is right here. All right, that means I have a point on the other side, right? At 0, 2. Let's go one more. Let's go 3. Again, I'll put in 3 where the variable is. 3 minus 1 is 2. 2 squared is 4. 4 and 1 is 5. And I've got the 0.35. All right, I'm 2 to the right of the line of symmetry. I'll go 2 to the left. And we're right there. Okay? All right, you go back to your inequality. What is it? It's a greater than. It's not greater than or equal to. This means the points of the line are not included. Therefore, I must use a dotted line. dotted line. Okay, and I'm a shade. So again, I'm looking at my inequality symbol, greater than. What is greater than? Greater thans are above the line, less thans are below the line. And so with a parabola, the greater than values are going to be in here. Okay, and that's the blue one. You can do a test point if you want, but that's the way it's going to turn out. You know, do 0, 0 as a test point. You'll find out it's not true. Is 0 greater than negative 1 squared is 1, 1 and 1 is 2. Is 0 greater than 2? No, and the test point fails. But again, it's a greater than. It's above the line, above the curve, above the parabola. And so we're shading up there. Okay, let's do the green one. So you look at the green one again, we need to determine, is this a max or min? This is also a min. That means it also opens up. What are the coordinates of the vertex? 1, 3, the HK values, right? Don't forget, HK are the values of the vertex. And so it's min at 1, 3, therefore the line of symmetry is x equal 3. All right, so let's go to 1, 3. So we're up here. Okay, and my line of symmetry is still right along that same axis. Okay, XY chart from here. Again, my vertex is already at 1, right? So I'm going to go one next value to the right, and that's 2. Now you're looking up here, and let me give myself a little bit more room here so I can, oh, we didn't want to do that. All right, let's see if we can get back to the right place. All right, right about there. Let's see if I can select that. Let's move it over a little bit. All right, we'll get there. Come on, 2. Got to talk to it. It really helps. All right, it just gives me a little bit more room, and I can show you what we're doing. Okay, so we're going to take the function here. Oh, don't want to do that. All right, we're going to take the function. So what do I have? A half, and then where the x is, I'll put in a 2 squared plus 3. All right, 1 squared is 1 times a half is a half, and what do you get? 3.5. So I'm at 2, 3.5. So right here, other side of the line of symmetry right there, right? 2, 2, 3.5. Therefore 0, 3.5. Okay, let's go to 3. So again, half, 3 minus 1 quantity squared plus 3. 3 minus 1, I'm looking right here, right, is 2. 2 squared is 4. 4 times a half is 2. 2 plus 3 is 5, right? So I'm at 3, 5, right there. Other side of the line of symmetry, right there. Okay, and let's do another point. Let's go 4. Half. Oops, that's a 4. All right, half. Put a 4 where the x variable is. All right, look right here. 4 minus 1 is 3. 4 minus 1 is 3. 3 squared is 9. 9 times a half is 9 halves, or what? 4.5. 4.5 and 3 is 7.5. All right, so 4, 7.5. Right there, and I am 3 to the right. Got to go 3 to the left. Okay, I look back at my symbol. And let me clean this up a little bit here. Let's get rid of this. Wow, very slow on my responsiveness there. Okay, so if you take a look, we've got a less than or equal to. All right, that means the points of the curve are included in the solution. So it's a solid line. And less than. All right, those are the values below the curve, right? We're going this way. Anything below the curve. Again, you can use a test point if you don't know how to do that, but that's pretty simplistic. It goes actually all the way to here. Okay, now remember, we've just graphed the two parabolas, but we haven't shown the solution to the system yet until we shade the solution set. And where is it? Right in here. Right in here. And remember, the lines of the parabola right here are included because it's both green and blue. All right, awesome. Beautiful, right? Okay. All right, a little bit of art there for you. You see how artistic I am. That's the solution, the points of intersection. Okay, that's the idea of systems. Let's do one more example here. One more example. All right, got a couple more parabolas. And so same scenario, we're going to graph these the same way. So we take a look and we say, hey, this is a min. All right, opens up. Vertex coordinates, remember, it's x minus h, quantity squared. Therefore, that's a -1. And then the k is a -3. Line of symmetry, x equals -1, right? All right, remember, the first thing you always do is plot the vertex. -1, -3, I'm right there. Line of symmetry is right here. Boy, my orientation is off. Sorry about that. Okay, now I need an XY chart to continue on. You know, when I look at stuff like this, I look at the half. And I know if I go by twos, it's just easier. And I don't have to, I can avoid the fraction. So look, look at the graph here. I'm at x -1 right now is where my vertex is at, correct? So I want to go 2 away, and I'm going to go to 1. I'm going to go 2. So I go to 1. From -1 to 1 is 2 away. Therefore, now when I sub into the formula, look what happens here. I won't have any fractions. 1 and 1 is 2. 2 squared is 4. 4 times a half is 2. 2 minus 3 is a -1, and I get the point 1, -1. So let's plot that on your graph. 1, -1. 2 to the right of the line of symmetry. Let's go 2 left. Okay, and again, I'm going to go 2 more, and I'm going to do 3. 1/2, 3 plus 1, quantity squared minus 3, right? 1/2. Put in 3 where the variable is. Okay, let's look in here. 3 and 1 is 4. 4 squared is 16. 16 times a half is 8. 8 minus 3 is 5. We have the 0.35. We're right here. 3 to the right, 5 up. I am 4 to the right of the line of symmetry. I go 4 left. And therefore I'm at -5. Back up to the inequality. What is it? It is a greater than, not equal to, meaning the points are not included in the solution, and so I dot the line to know that. Anyone looking at your graph will know the points are not included because they see your dotted line. That is those that understand the math, right? They'll see the dotted line and say, oh, the points of the curve are not included. The equal to part is not included. And again, we have to shade, and it's a greater than. And where is greater than? Greater than is above the curve. So for us, everything in there. Okay, that's the first one. Second parabola. Second parabola. So we look at this and we say, oh, this is a max. Max open down. Max coordinates. Okay, look. This is an x minus 0 quantity squared. What's the h value? 0. What's the y value? 4. So this is at 0, 4. Line of symmetry, x equals 0. So we're going down, right? Opens down. All right, from here it's an XY chart. Look again at the original right up here, looking up there. Okay, if you notice, we got this -1/2. So again, we have a half. So I'm at 0 right now. That's what I've plotted the vertex, right? At 0 x value. That's 0, 4 is the point, but the x value is 0. I want to go 2 away, so I'm going to go to 2. 2 away from 0 is to 2. It's going to avoid fractions. All right, look at the original. 2 squared is 4. 4 times -1/2 is -2. -2 plus 4 is 2. So I'm at the point 2, 2. 2 to the right and 2 up. So 2 to the right, 2 up. I went 2 right of the line of symmetry, go 2 left of the line of symmetry. Okay, all right, let's go 2 more. We'll go to 4. Again, look at the equation. 4 squared is 16. 16 times negative a half is a negative 8. 8 negatives and 4 positives leaves you 4 negatives. So we're at 4, negative 4. 4 to the right and 4 down. I'm 4 right of the line of symmetry. I will go 4 left, and that is that one. Look at my symbol. It's a less than, okay? The equal to part is not included, therefore I use a dotted line to illustrate that. And it is a less than, all right, that's below the curve. That's down here. Again, if you don't trust me, you can do a test point, but that's the way it is. And where are the points of intersection? Everything in here. Everything in there. So really what we did was we reviewed graphing inequalities. Again, they could be a line, they could be linear. We've already worked on those. They could be parabolas. And hey, let me show you one other situation. Look at the graph. Let's suppose you had to graph a polynomial. What if you had a polynomial inequality? And it could be anything, but remember polynomials, and let's say it was we'll say it was a greater than or equal to. And let's say it was a positive cubed lead term. So something like y greater than x cubed and whatever else left. Okay, so we already learned, remember, because the lead term is positive, it's going to end up in the positive direction. Because the lead term is odd, it's going to start and finish opposite, right? And it can have as many as 3 directions because the lead term is cubed. So again, I'm just going to sketch something. And you don't need to do this in your notes. I'm just trying to show you one other probability. Let's suppose we had a 0 of negative 3 and a 0 of negative 1 and a 0 of 1. And perhaps this looked like this. And it were a greater than. Well, you'd be shading all of this, right? All of this above. And now you'd have to say the final solution to all of this. And let's see if I can. No, we don't want all that. All right, come on, pens. Crayon. Beautiful. All right, well, it's not great, but here I'll use black. So where do you see all of it? So we're above. So that would be the solution if we also had a third polynomial inequality. All right? Pretty cool stuff, I think. And so that's the idea. Hey, what's the biggest thing? We already know how to graph. We just got to really find the points of intersection. If you can remember that, you can solve systems of inequalities. That's the lesson. Have a great night.